It's time, isn't it? For example, number 3, literal equations. Here we are. We have this mathematical expression equation. The instructions are to solve it for n, which has become a very important point here in a bit. So, there we go. Let's go with the simplification. Clear fractions. Yes, there's a fraction here. Fractions represent division, and therefore they are counteracted with multiplication. And so the point would be we're multiplying both sides by that denominator there, because remember, this is over 1, and it's going to cancel. All right? So we'll introduce that same expression to both sides, 7m minus 5 times the fourth root of n to both sides. On the right-hand side, cancel. That's why we did it, right? That's why it's called clearing fractions, getting rid of a fraction. All right? So that just leaves the numerator over here. On the left-hand side, wouldn't that generate some distributing? So if we distribute the a to each of the terms in the parentheses, that's going to give us 7 times am minus, and then we'll take it times that term, and that'll be 5a, and then the radical. All right. Hopefully, again, you can see these things. Feel free to pause at any time. And zoom in if you need to. I'm doing the best I can. I know you're doing the best you can. Let's just make the most of this. All right? So anyway, is the variable in one term, and that variable is n. So I look here and I notice there's an n there. One place. So I would always tell a person that's the better scenario, in my opinion. Let's just start using inverse operations to isolate that variable. And it all goes back to the order of operations, parentheses, exponents, multiply, divide, add, subtract. Which of these is furthest down the list from the variable n? So, after talking that through, I hope you would say, look at that 7 a.m. out there. That's like adding 7 a.m. That's way down the list. Let's subtract the 7 a.m. from both sides. And you're probably thinking, man, I sure wish I could subtract 7 a.m. from my life. You young people probably aren't even up by then, 7 a.m. Oh, here I go, crabby old man. You young people. All right. So anyway, I'm just jealous. So here's n again. Again, if you go through the order of operations, you would hopefully agree with me that this is multiplication of the negative 5a, and therefore that would need to be divided. Look, I'm just going off of what people have understood in the past, so again, I don't have the ability to get any feedback from you, but in the past, students have looked at me and either nodded in agreement or perhaps nodded off. But anyway, if we do that move, and let me get my dear Aunt Sally out of the way. Sorry, Aunt Sally. So the radical is left over here. The negative 5a canceled. And then we're left with negative 7am plus 4b plus 3c all over negative 5a. So this is just kind of unraveling the equation one step at a time. And then, of course, you get rid of a fourth root with a fourth power, right? Kill the radical, magic exponent, all right? Now be careful if you're going to apply the fourth power to this side. Just put the whole side in a grouping symbol, parentheses in other words, put a fourth power on it, okay? So this gets rid of this. We're left with n all by itself, and we just copy this down. Negative 7am plus 4b plus 3c all over negative 5a, parentheses, fourth power, n is by itself. We just generated a new formula. Sometimes people ask me, where do math formulas come from? And frequently the answer is other math formulas. You take one and you rearrange it. All right, so anyway, we'll work our way here. Hope you enjoy this little clip while we transition.
Falls over the crowd as Cooper studies the board. He makes his move. He's dividing both sides by I. He's adding back the coefficient. He has a value for p. Plugging that back in, he takes the derivative and he solves the equation. The crowd goes wild. No, Bill! No, Bill!
He solves the equation. The crowd goes wild. No bell. No bell.